And Assalamualaikum everyone, we are from CS1121A. We're gonna talk about application of differentiation. Before that, I'm gonna introduce our member, and our first member is Afrina Farzana binti Ahmad Fauzi 2021864118, and our second member is Nur Sofi Al-Inshira binti Nazi 2021687564, and our third member is Alia Liana binti Ismail 2021867012.
First and foremost, the completion of this group assignment could not have been possible without the participation and contribution of our group members. We managed to finalize the video within the time given thanks to so many people. We would like to express our sincere gratitude and deep appreciation to our lecturer of this particular subject, Madam Roslah binti Arsad, for teaching us in excelling Calculus 1. Not to mention the guidance and willingness in helping us to fill what we are lacking while completing this assignment. Our sincere thanks also go to our family and friends for their endless support.
Related rates. What is related rates? Related rates is finding a rate which quantity change by relating that quantity to other quantities whose rates of change are known. Related rates is when you try to find the rate of change of two or more variables that are related to a common variable, namely time. For example, like dx dt. To solve these types of problems, the appropriate rate of change is determined by implicit differentiation with respect to time. Rate of change is positive if the dependent variable increases with respect to time, and negative if the dependent variable decreases with respect to time. The sign of rate of change of the solution variable with respect to time will also indicate whether the variable is increasing or decreasing. We have seen that quantities that are changing over time, the rate at which these quantities change are given by derivative. If two related quantities are changing over time, the rate at which the quantities change are related.
Next is method of differentiation. We applied the implicit differentiation in the question given. In implicit differentiation, we differentiate each side of an equation with two variables, usually x and y, by treating one of the variables as a function of the other. This calls for using the chain rule. Here, we treat y as an implicit function of x.
Why do we use differentiation and related rates? The reason why we use related rates is because it requires two variables that are respect to time. Meanwhile, differentiation of chain rule is applied here. Problem solving. An airplane flying at 450 km per hour at a constant altitude of 50 km. And the airplane is approaching a camera mount on the ground. Let theta be the angle of elevation above the ground at which the camera is pointed. When theta equals to pi over 3, how fast does the camera have to rotate in order to keep the plane in view? Now, here is the solution.
We know that dx over dt is negative 450 km per hour, and want to find out what is d theta over dt when theta equals to pi over 3. To answer this, we need to understand how x is related to theta. First, we know tan theta equals to pi over x. Step 1. Differentiating tan theta equals to pi over x with respect to t and with chain rule. First, differentiate tan theta, and you will get sec squared theta d theta over dt. By using reciprocal identity, you will get 1 over cos squared theta d theta over dt. Second, differentiate 5 over x, and the answer will be negative 5 over x squared dx over dt. Put them together and you will get the equation. Step 2. We want to calculate d theta over dt when theta equals to pi over 3. Since pi is 180 degrees, so theta equals to 180 degrees divided by 3 and you will get 60 degrees, which can be seen in the diagram. At that moment, cos theta equals to 1 over 2 and tan theta equals to square root of 3. Step 3. Find the value of x. We know that tan theta equals to 5 over x and tan theta also equals to square root of 3. Hence, square root of 3 equals to 5 over x and you will get x equals to 5 over square root of 3. The last step is substitute. Note that cos theta is equals to 1 over 2 and x is equals to 5 over square root of 3. Substitute it in the equation and we'll get the answer, which is 1080 radians per hour.
This is the conclusion. The airplane is flying at a constant altitude which is approaching a camera mounted on the ground at 450 km per hour of 5 km. We can apply the implicit differentiation, chain rule, and special angles formula when solving the problem that involves finding the d theta over dt. This is the references. We use these 4 links that listed as our reference.